Definition. Straightness is a form control that may be used as a surface, b. derived median line DML, c. derived median plane DMP. If straightness form control is used as a surface control, deviation from a perfectly straight surface must be contained within the feature's MMC limits of size. Surface straightness controls use only a straightness symbol and a geometric tolerance zone descriptor. Straightness control. Straightness is an individual control not related to any datum. Therefore, no datums are allowed in the feature control frame. But the controlled feature can be the datum itself to which other features are controlled. In that case, it may be represented as shown. For a cylindrical feature, the straightness control defines that each longitudinal element of the controlled surface must lie between two parallel lines which are the allowed geometric tolerance apart and in a plane common to the nominal axis of the feature. Straightness of a derived median line. The straightness control applied to derived median line is used to control the straightness of lines defining the axis of cylinders, etc. Therefore, the tolerance zone is described as a cylindrical shape and therefore with derived median line, straightness as a diameter line is included in the control. When applied on an MMC basis, the maximum straightness tolerance applicable to the produced feature is the specified tolerance plus the amount the actual local size departs from MMC. As each produced local size departs from its MMC, an increase in the local diameter of the straightness tolerance zone occurs that equals the amount of departure from MMC. Straightness of DML continued. Therefore, a new boundary is generated by the MMC size of the controlled feature and its straightness tolerance. These boundaries are often used to determine worst mating condition sizes for mating features or functional gauges. If the feature of size is controlled with MMC material condition symbol, a gauge can be made to check the form. This gauge is called functional gauge or receiver gauge. This gauge will be made to the virtual condition of the feature of size it is to check. If the controlled feature is a male feature, shaft, tab, boss, etc., the receiver gauge will resemble its female counterpart in shape, hole, keyway, ring, slot, etc., and vice versa. Straightness of a derived median plane. In straightness of a derived median plane, the tolerance zone begins as the distance between two parallel planes and runs through the center of the controlled feature of size. The controlled feature's derived median plane as determined must lie within this tolerance zone. The derived median plane is generated by the opposing points on the surfaces which make up the controlled features of size. The derived median plane generated may bend, waffle, or distort in any way from a perfectly flat counterpart, but must never violate this tolerance zone of two parallel planes the distance apart allowed by the control. Straightness of a DMP continued. When the MMC symbol is specified, this tolerance may grow. When applied on this MMC basis, the maximum straightness tolerance applicable to the produced feature is the specified tolerance plus the amount the actual local size departs from MMC. The inspection setup shown is one that employs adjustable supports, fixed supports, a surface plate, and dial indicators. The median points are found by comparing the readings on the indicators at M1 and M2. This may be viewed as each indicator recording shows a height from the surface plate to the surfaces. Once the center point is found, it should be plotted on a graph. If enough median points are plotted, a graphic display of the DMP emerges and is assessed for compliance with the 0.25 geometric straightness tolerance.